Hello, I'm Megan. When you look around, have you ever wondered, what is everything made of? Well, for centuries now, we have understood that everything is made up of these tiny things called atoms. Now, our understanding of how atoms fit together, what their parts are, and how they behave has changed over time. I will explain to you what we now know about the atom, which is that it has a nucleus, which you can think of as a ball in the center, and the nucleus contains positively charged protons, and it contains neutral particles called neutrons. Now, surrounding the nucleus, we have different energy orbitals. Just think about the rings around Saturn. And in these rings exist the negatively charged electrons. So keep in mind going through this history here that opposites attract. So negative and positively charged particles, think of magnets, attract. They're drawn to each other. So back in 1808, a guy named Dalton, he proposed that atoms are extremely small particles that make up each element, for example, gold. And all particles of each individual element are the same. So in a sample of gold, all of the gold atoms would be the same. In a sample of copper, all of the copper atoms would be the same. So essentially, his model became known as the billiard ball model because he kind of just thought that these atoms existed and everything kind of just bounced off of them. So this was one of the earliest models of the atom, and that's what it would look like. So then in 1897, a guy named Thomson came around and he discovered that atoms have the positive and negatively charged particles. His description became known as the plum pudding model because it resembled a ball of positive charge with negative charge distributed throughout, like the raisins in plum pudding. So going to our simulation here, this is what the plum pudding model looked like. And you can see there's a tiny little blue dot there, and that is an electron. That is the negatively charged particle floating around in that positively charged red goop there. So moving on from 1897 to 1908, we have another man named Rutherford. Now he came in and he introduced what became known as the planetary model. So he predicted that atoms contain a nucleus, and that the nucleus contained most of the mass, and that in addition to the positively charged protons that were in the nucleus, there were electrically neutral particles called neutrons. So that's in the nucleus there, makes up most of the mass, and he suggested that the electrons kind of just whirled around the nucleus, kind of like a cloud hovering. So the problem with that is, remember when I said opposites attract? Well, the positively charged protons in the middle and the negatively charged electrons, if the electrons are just floating around kind of willy-nilly in a cloud, what's stopping them from crashing into the nucleus, into the positively charged protons? So, moving forward, in 1913, Bohr came along, and he proposed that electrons were restricted to fixed orbitals and were only able to emit or absorb energy when they moved from one orbit to another. He also posited that electrons didn't always act like particles. The problem here was that the Rutherford-Bohr model now could only be made to work in atoms with one electron, for example, hydrogen. Now, Bohr's model, what became known as the Bohr-Rutherford, this is a combination of the two, model looked like this. So the little red dot in the center there is the nucleus, and then you have these energy orbitals, and the blue dot going around is an electron. So again, this only worked with atoms that had one electron. So moving on, in 1925, another guy named de Broglie theorized that electrons behaved like waves of light rather than particles. But further experiments showed that they didn't behave entirely like waves of light either. And then in 1926, Schrödinger introduced a quantum theory that electrons behaved both as particles and waves. This became known as the wave-particle duality. So as you can see, science and our understanding of it has evolved and changed over time, and we are continuously learning more. Going ahead in chemistry with the atom, you will most commonly see the Bohr-Rutherford model, or what's known as the planetary model, which is this one. It has been the most useful for us in science today in understanding the way that the different particles work and how they fit together. Have a good day.